Both ways possible. Closed surface, only outward. These points you keep it in mind. So now we can move to the electric flux. Electric flux is a physical quantity represented by phi. So it just links, okay? It is a link. Electric flux links or gives the relation between electric field lines and the area in consideration. So it is a measure of electric field lines passing through a given area. That's all. It is not a new term. See, in order to see now, okay, let me explain this. How it depends on. The electric flux is represented by the symbol phi and it is given by the formula EA cos theta. Okay. So why it is EA cos theta? Because electric flux depends on two quantities. Okay. The first one is it is directly proportional to the area through which it is passing through, and it is also directly proportional to the perpendicular component. This E cos theta is known as perpendicular component of electric field. So one by one we will see what is the relation. If I give you, this is the number of electric field lines passing, okay, this thing. And I am having two squares loop, okay, square loop you take it. Or area you can. So now tell me, in which square the electric field lines will be more in number? Obviously from the figure it is B, right? Correct? B is bigger. So number of field lines passing through the area B will be more in number.
Ma'am, B.
Yes. Is that clear, everyone? So B will be more than. So what does it shows? The number of field lines passing through the given area. It depends on the area. Correct? So that's why phi is directly proportional to area, more number of field lines. It's like door. If it is a big door, at a time 4 persons can pass through. If it is a small door, then one by one you have to pass. Like that only, bigger area, more number of electric field lines. You can imagine like it's passing through the given area, everything. I hope you understood this point. So the next point is, what is that? If the given area, see, consider this one area and assume that the electric field lines are passing in this way. By definition, what is the electric flux definition? It is the number of field lines passing through. I have not given the definition. See, this is the general definition. Let me write. Okay. By definition, write it here. The electric field flux is given by what? Number of electric field lines passing normally through a given area. That's what you should write, okay? Passing normally through a given area. Normally means what? It is perpendicular, right? So we consider only the electric field lines which are passing perpendicular to the given area. Now you look at this. This makes an angle. Where is the area vector for this now? Even if you consider the horizontal line, where it will be in this direction, right? It makes an angle theta with the x-axis. Yes or no? Whenever any vector making an angle theta with x-axis or y-axis, immediately what did I say? You have to resolve that into two components. One is horizontal component, parallel component, that is adjacent side of theta, that you will consider it as what? E cos theta. And the other one is perpendicular to the theta, which is given by E sin theta. You remember the resolution of vector? You can resolve into two components. When it is making an angle theta with x or y axis. Just consider, first draw the vector and you just mark the theta. Nearby theta, the adjacent side is cos theta always. The perpendicular to the theta will be sin theta. So now we have got two things. Now you just draw this here. So what it is? This is E sin theta component and this is E cos theta component. Similarly here E cos theta and this one will be E sin theta, right? So now tell me, as per definition, what is electric flux? It is a number of field lines passing normally through the given area. Which lines are passing? Which component are passing through normally, ma? The E cos theta component only normal to the surface? Yes or no? So this component only we should consider. So now tell me phi is directly proportional to E cos theta. This is E sin theta is lying parallel to the surface. It is not cutting the surface. It is just passing parallel to the surface. Is this point clear or no, everyone? If this is clear, then together you write it will be A and E cos theta. If you remove the proportionality sign, you can find it out as 1. So phi can be given as EA cos theta. So in dot product, what we have seen in the class 11, dot product is given by A dot B. That is nothing but AB cos theta. And A is a vector, B is a vector. But AB cos theta, the resultant is not a vector, it is a scalar. So no need of direction. Similarly, here area is a vector. Now you understood why we have considered area vector. Area is a vector, electric field is a vector. But when you dot product it, what you are getting? Phi, which is a scalar quantity. So how can I write this? It is nothing but the dot product of electric field and area vector E dot A. Can I write like this? And where theta is the angle between E and A?
E and A, yeah.
So electric flux, is that clear? So definition is very simple and you can remember. The only thing is when you do the numericals, you should find it out properly. Here is it clear? So what is the SI unit of electric flux? It is E. For E it is Newton per Coulomb. For area it is meter square. So Newton meter square per Coulomb. Next step, you know that. What is that next step? It is nothing but dimensional formula. So dimensional formula is given by for Newton. What you will write, ma? ML, MA. Force is MA, right? ML T power minus 2. For meter square, L square. For Coulomb, current into time. So AT. So it is nothing but M L cube T power minus 3, A power minus 1 is the dimensional formula. Is it clear or no? Any doubt you can let me know. Everyone?
Yes, ma'am.
And now the next important point is by convention, okay, inward flux, that is inward electric field lines, inward flux will be taken as negative, okay, and outward flux will be taken as positive. And here you add one more thing, the theta can be between 0 to 90 degree. What is the maximum value of cos theta, ma? It is plus 1, right? So the flux can be 0 to 1. Flux is a scalar quantity. So don't write minus 1. Okay, so it will be maximum to minimum. The angle can be vary between 0 to 90 degree. That means I have to write like this. The points can be 1 to 0. The value can be. This is the maximum value. This is the minimum value. When the flux will be maximum and minimum, you are telling. So this is 1, 2, 3, and this one is 4, 5. When flux will be maximum? Equal to EA cos theta, right? That means theta should be equal to 0. Then cos theta will be 1. So that means EA cos theta will become EA. So this is the maximum flux. That means what? Electric field lines and area vector are parallel to each other. Now you will say you have understood this. The point is, you have to first consider the area vector. For a given surface, this is not area vector, this is the area vector. Okay, and the electric field lines should pass like this. Angle between E and A will be 0. You should not consider this plane as your area vector. That point I have seen in my experience. When you do the numericals, here you will just, you get the confusion. But while learning itself, you learn it thoroughly. The first step you will do it, mark the area vector, and then find out everything. Clear, ma? Everyone? Area
Yes, ma'am.
Next case, when it will be minimum? I will be equal to 0, because when theta is how much? 90 degree, cos 90 is 0. That means flux will be 0. In this condition, electric field is perpendicular to. So the same example I will take. Here, this is the area vector, correct? And if the electric field lines are passing in this way, so what is the angle between them? This is 90 degree. So in this case, the flux will be 0. Here, that means electric field is perpendicular to A. For any other angle, for all other angles, I is given by EA cos theta. All these points clear?
Yes, ma'am.
Good. So now I will move to this one. How to find the electric field? Sorry, electric flux. Now this is X, Y, Z. So what is the area in consideration? Now tell me, ma. If this is a square, A I have given. Area vector, find out the area vector direction first. It is in a YZ plane. Area is in YZ plane. Okay, rectangle is placed in YZ plane. Rectangle or square is placed in YZ plane. Okay. Find electric flux through it if electric field is given by 2J Newton per Coulomb. So first, any one of you tell me, Vinu, tell me where is the area vector? Okay, so this will be the area vector direction. Now, which is nothing but I, you can take it directly. Electric field is along, this is area vector there. Now, in which what is given? Electric field is given by 2J Newton per Coulomb. J represents what? The electric field is along y-axis. Okay? Remember that when J is given, electric field is along y-axis. And it is constant value. Why is it constant value? It is magnitude is only 2. There are no other variables. If it is given 2yj, then we can say that when you put values for y, the E will keep on increasing. Here it is not variable. Here the electric field is constant.